For a long time, house building materials have been selected on the basis of fashion, price, and availability. That's changing. Designers and their clients are having to think about the carbon footprints or embodied carbon that different building materials have. As the first video in this series pointed out, there are two key sources of carbon in buildings: embodied carbon in the materials and operational carbon from energy use when the building is occupied. If we focus on New Zealand's net zero carbon date of 2050, the contribution made by materials is significant, as most of the emissions from materials occur early in the life of a building. Just focusing on reducing energy use in our houses won't be sufficient to reach the net zero carbon target. As was also discussed in the first video in this series, carbon from materials needs to be considered across the life cycle, from manufacture to maintenance, replacement, and disposal. There are life cycle tools on the BRANZ website that help you compare the environmental impact of materials over their entire life. Some issues to address in materials selection are concrete slab or suspended timber floor. If you opt for concrete, consider use of concretes with supplementary cementitious materials. These concretes contain alternative materials that replace some of the cement in the concrete, cement being the part that has a high carbon footprint. Ask concrete suppliers what they can do. Bear in mind, when programming the build, these sorts of concretes can require a longer curing time. Also remember, the concrete slab should be exposed and adjacent to large, north-facing windows to make use of its thermal mass during wintertime. Suspended timber has lower embodied carbon, but a higher cost. If you opt for a suspended timber floor on timber piles, it is important to check that the timber comes from certified sustainable forestry, for example with FSC or PEFC certification. This ensures that the forest owner is planting at least more trees than are being removed, providing new trees to sequester atmospheric carbon dioxide. Not knowing where timber comes from risks inadvertently sourcing from unsustainable forestry operations. Do you really need a material? For example, does a floor covering such as carpet or floor tiles have high embodied carbon? How often will it need to be replaced over the course of its life? If carpet is placed on concrete, it greatly reduces the benefit of thermal mass. Some flooring materials can work well as the finished product without a floor covering, for example polished concrete or timber floors. Roof and wall claddings are key elements of the thermal envelope of a house, so it is important to select systems that will provide good thermal performance with lower embodied carbon. The carbon footprint can vary significantly depending on the materials and how much of them are used. There may be good reason to specify a material that has a marginally higher carbon footprint than alternatives if it contributes to better thermal performance. As with claddings, the windows are a key element of the thermal envelope. Aluminium windows with a thermal break in the frame and low E coating on the glass may have a slightly higher carbon footprint, but this is offset by significant benefits in thermal performance. How and where you install windows also contributes to their thermal performance. BRANZ evaluation methods number 8 and number 9 can help here. Look at large structural elements. For example, is it possible to replace a steel beam with a lower carbon option such as LVL? Decisions around materials involve balancing a range of factors, from the volume of the material used to its durability, the maintenance it requires, and any offsetting benefits it may have, such as increasing thermal performance. Designing to reduce waste is important to reducing the carbon in house construction. Construction and demolition waste makes up 40 to 50% of New Zealand's total waste going to landfill and cleanfill. When a material is wasted, it has been manufactured and transported only so it can go to a landfill site. Reducing waste reduces emissions. Some useful steps: keep the range of materials to a minimum and reduce design complexity. Use modular sizes in design to reduce offcuts and increase the use of off-site panelized construction. Arrange surfaces to be compact with minimum runs, for example by grouping all wet areas on plans. Select locally manufactured materials where possible. Select prefabricated elements where possible. Source sustainable, reused or recycled materials. Plan for materials to be reused or recycled rather than going to landfill. For example, specify bolt or screw fixings rather than adhesives. Require the building contractor to have a site-specific waste management plan. When you want to find the carbon footprints for specific construction materials or house designs, BRANZ tools can help. BRANZ CO₂NSTRUCT provides embodied carbon and energy values for building materials. LCAQuick evaluates the carbon footprint of a building design across its life cycle. The Core tool compares the carbon emissions and R values of common residential constructions. And the NZGBC Materials Carbon Calculator, used for Homestar version 5. Other tools are on their way, so keep your eyes on the BRANZ website and on the Build magazine.